session, we are going to discuss on how to solve first-order non-separable DEs. Now, for you to understand what non-separable is, at the beginning, we reviewed on an item, and there you would see that you can manipulate that item in order to solve the differential equation. However, not all items are like that. I'd like you to observe the two sets of examples, the ones in red and the one in blue. Now, majority of the students might mistakenly say that they are just the same, but the truth is they are not. The ones in red are the ones we usually integrate, wherein they are with respect to a certain variable, either in x or with respect to y. But the ones in black, if you try to look at it, we are integrating x without any reference. You cannot say it's dx because this is plus dx, meaning this is a separate expression, different from this. Alright? Same is true for this one. We cannot say that the y squared is with respect to dy because again, we are separating the two terms. In other words, this brings us examples of non-separable equations or differential equations. For you to understand further, let's have this particular example. So if you recall, if we are to solve this one, we usually write this as dy over dx, if you recall, equal to 2e power of x minus 2y. And so what we usually do here is we try to transfer this to the other side, so this becomes dy over dx, for example. You have plus 2y equal to 2e raised power of x. This is what I'm telling you. Majority of the students would say that this will just be the same as with respect to y, when in fact it isn't. Now, if you try to simplify this further, all right, multiplying everything by dx, okay, this now becomes dy equal to 2y dx equal to 2e power of x. Dy this is dy plus 2y dx equal to 2e power of x. Okay, so here if you try to look at it, we cannot proceed because this is with respect to x. Again, whatever you do, you will come across a term which cannot be written the way we used to write them, and that makes this non-separable, so we cannot separate them. So the question now is, how do we solve non-separable differential equations? Okay, so to solve non-separable differential equations, we need to follow certain forms, which I'd like you to be mindful of. Starting with the first form, which is this one. So to solve non-separable differential equations, write or rewrite the given into this form, wherein the term or the expression containing the y should be written close to your y prime. Or if this is x prime, the term containing the x should be placed beside the x prime. Again, it depends on what the given is. Since we're given y prime, the derivative of y with respect to x, so it should be the term containing the variable y placed beside the y prime. Okay, so if we follow this form, this becomes y prime plus 2y equal to 2e raised to the power of x. Now, if you try to compare this with the given format here, we can now conclude that it seems like your p of x is equal to 2. So p of x is the expression together with the variable y. It could be an expression with x, or it could be a constant, a coefficient. All right? So in this case, it's just a number, a numerical coefficient. So your p of x is equal to 2. And your q of x, the remaining expression containing x, which is left at the right side, q of x is equal to 2e raised to the power of x. Okay? Now, to complete, we actually need to find your I of x, which we call as the integrating factor. So the integrating factor will just be e raised to the power of p of x dx. In other words, We need your p of x in order to find your I of x. Okay? To continue, if we substitute your p of x here, this becomes, all right? And then simplifying further, you will get e raised to the power of 2x. So this is now your this is now your integrating factor, e raised to the power of 2x. Once you got all three, you're now ready to solve this differential equation. And this is another form that you need to remember. You need to be very particular with. Solving differential equations will just be, or this is a first order differential equation, by the way, meaning the exponent would be 1 for both x and y. So it will be y equal to this particular form. We're in 1 over the integrating factor multiplied by the integral of the product of the integrating factor and that q of x dx plus c gives you the solution to the dE. Okay? So once you have all the given which you were able to find out early on, you can just simply substitute. Alright? Then simplify. Since we are multiplying two expressions with the same base e and e, exponent law tells us that we can add exponents. Thus, we can simplify this further into this. And before we proceed at integrating this, we can just put 2 outside because 2 is a constant. Therefore, we are now ready to do our integration. So the integral of this, remember, is just simply 1 over 3 because of the exponent, e raised to the power of 3x. So 1 over 3 times 2 will give you this particular expression. So this is now being simplified directly. All right? So from here onwards, we can just simply multiply this to both terms. Thus, we get this one. And from here, you can see that we are we're dividing rather two expressions with the same basis. Exponent law tells us that you can subtract the exponent. Thus, you can simplify this further into this particular expression. And this gives us the particular solution. All right? This gives us the general, not the particular, the general solution. However, if you're given a condition, certain value of y, given certain value of x, you can go forward and solve for the c. So all you have to do, remember, we did this last time. It's still the same process, so I won't show you the solution anymore. But what you can do here is substitute the values of y here and the value of x here, and then solve for the c, which in this case, c is 12. So once you have found the c, then you can substitute it to the general solution in order to get the particular solution. So this is what we call as the particular solution. Now, how would you know if this is correct? How to check? To check if this is correct, we actually need both your original equation and your solution, which is this one. All right? Now, we just need to prove that when we find the integral of this, it should equal to 2e raised to the x minus 2 times y, by which your y is given with this expression. In other words, we need to substitute the expression for y here and the expression for y prime here. Alright? And you need to prove that they will be equal. And that's how to check if your answer is correct. Your previous answer if it's correct or not. Now, in my case, I wanted to manipulate this to make it quite simple for me. So I'll just put all the y's on one side equal to 2 times e raised to x. So I could write this into this format so that my focus will just be to prove that if I combine my y prime and my 2y, I will get a 2 times e raised to x. Okay, so my focus will be this. So to complete, let's just find the derivative of this, which in this case I am assuming that you know how to find. Okay, simplifying it, therefore this is now the derivative of the y. Again, since this is the manipulation I did a while ago, I need to show that when I substitute this expression here plus 2 times the expression of y gives me this expression. If it will, then this answer is correct. If it's not, then there's something wrong with my answer. So let's try to check. Substitute. This is now for the y prime. Try to see. This is now for the y. And we just need to simplify them. Okay? Now, if you try to look at it, we find here two contrasting terms by which we can just cancel them, equal to 0. Thus, we get this simplified form, combine like terms, the fractions, and simplify further, thus we get this. Since we arrive at a true equation, we have verified that this will really lead us to this particular expression, so we are now confident that our previous answer then is correct. Therefore, the solution to this differential equation is then this one. Okay? Let's have another example. Suppose we have this. Alright? Again, write this in this form. So in order for you to write this in this particular form, you need to do manipulation. So you need to carefully analyze and study how to arrive at this particular form. There are many ways. You can do different ways. One way by which you can do in order to achieve this form is to divide all terms by x minus 2. So divide this by x minus 2, x minus 2, and x minus 2. The reason for that is when you divide this by x minus 2, you will be left with y prime. At least that's already y prime. Alright? So this now gives us this particular expression. Now, if we try to look at it, we can simplify this further because this is factorable. So when we factor this out, we can cancel common factors, thus we get this. From here, we can now compare it to this form, thus we can say that your p of x is the one beside the expression beside the y, and the one left at the right is your q of x. Okay? So what we are left now is your integrating factor. Again, integrating factor can be solved using this particular form. So substituting your p of x here gives us this, the integral of 1 over x minus 2. So you can use your reverse chain rule here. And when you find the integral of this will give you e raised to ln x minus 2. Remember your laws of logarithm. If you have this form here, if the exponent of e is ln, then that could just be simplified as x minus 2. Alright? So now you have your integrating factor, so you can now proceed at solving this differential equation. Recall that this is the form we need to solve the differential equation. So all you need to do here is just to substitute, alright, and then simplify. So x minus 2 and x plus 2 can be simplified further. We can multiply this to make it a bit simpler. So we can now have this one, and then later on you can proceed at finding its integral. So let's go to the next slide. So we ended up with this, if you recall. So finding the integral of each term leads you to this one. All right? And of course, final step, multiply this to each of the term. Thus, we get this. All right? Now, take note, usually, we write the denominator for the c on top. That is why we usually write it with a negative exponent. This is also true to my first example. So if you have an expression in the denominator with a c, you have to write it on top using the law of exponent, negative exponent law. This is now our general solution. Now, if you're given conditions, values of y and x, by which you can substitute this value to this and this value to this, to all the x's here, you can actually solve for the c. So your c here is actually equal to 6 when solved. Again, we did this already last week. Okay? So once you have the value of c, then you can proceed at getting or giving your particular solution. Alright? And that's how to solve differential equations. Now, what I'd like you to do, please pause this video and answer these 4 items. Alright? The first one is the one I gave you at the beginning. So you can now attempt at solving this. Afterwards, you can proceed at looking at each answer. So my suggestion is answer one item, then look at the solution, then proceed at answering the second item, pause the video, after which look at the answer, and so on and so forth. Thank you so much, everyone.